This video is going to continue Chapter 14 of Geometry. It's going to cover 14.7 through 14.9, and we're going to talk about proofs and the three different types of proofs. So by the end of the video, you should know the differences and how to do these different types of proofs. We're going to start out with direct proofs. So in a direct proof of a logical argument, the given information or premises are stated. So we have our premises. Then valid patterns of reasoning are used to arrive directly at the conclusion. So in the last video, we covered these valid patterns of reasoning. And then a two-column proof is a type of direct proof where each statement in the logical argument is written in the left-hand column, and the reason for each statement is written directly across in the right-hand column. And essentially, to show that an argument is valid, you use a direct proof. So now I'm going to go through an example of a direct proof. So here are our premises. We're given if P, then Q. We're given if R, then P. And we're given not Q. So we know that not Q is going to be true. And we're trying to prove that not R is true. So we're going to do a two-column proof. So we're going to start with our premises. So 1, we have P, if P then Q, and the reason for that is that it's a premise. And then we have 2, not Q, and the reason for that is also that it's a premise. And then from this we can conclude that not P is true, and that's using lines 1 and 2, and then using MT, which states that if you have if P then Q, and if you're given not Q, you can conclude not P. And then we're going to go on and say we're given if R, then P, and that's also a premise. And now we can actually do the same thing again, where we conclude that therefore not R, using the exact same thing, lines 3 and 4, and MT again. And now we've proved that the conclusion of not R. So this is the second type of proof. It's called a conditional proof, and it's used to prove that an if P then Q type of statement follows logically from a set of premises, and therefore a conditional proof begins with an assumption. So an antecedent is the first part of a conditional statement, and it's assumed true. And then a consequent is going to be the second part of the conditional statement, and it's going to be, and logical reasoning is used to demonstrate that the consequent is true. And if successful, it's demonstrated that if P is true, then Q must be true. So essentially, a conditional proof shows that the antecedent implies the consequent. So now I'm going to go through an example of a conditional proof. So here are premises. We're given that if P, then R, and we're given that if S, then not R. So, and we're trying to prove that if P, then not S. So here's our proof. So we're going to do a two-column proof again. So we're going to start with 1P, and then the reason for this is that we assume the antecedent, which is going to be the first part of our conditional statement, which is symbolized here. And then we're going to say, so if P, then R, and this is a premise. And then we can conclude that R is true because we assumed that P is true, and that's using lines 1 and 2 and MP, which says that if you have if P then R, and you say that P is true, then R must be true. So then 4, we're going to say if S, then not R, and that's a premise. And then we're going to say that we can conclude not S from lines 3 and 4 using MT, because we have R, so that's essentially a double negation of not R, and that's using MT, which normally says that if you have not R, then you have not S, but since we have not R here already, it's going to be if we have R, then we have not S. So then we can say that assuming P is true, the truth of not S is established. So we have, therefore, if P, then not S. So this is our final type of proof. It's the indirect proof. And in an indirect proof, all possibilities that can be true are recognized, and then all but one possibility are eliminated when they are shown to contradict some given fact or accepted idea, and then it must be accepted that the remaining possibility is true. So now we're going to do some practice with indirect reasoning, which is directly related to indirect proofs, and this can actually be really helpful even outside of math, so it's a test-taking strategy as well. So if we're, for example, given the question, what is the capital of Mali? A lot of people don't know that, but if we're given some answer choices, we can use indirect reasoning to find the right answer. So let's go through these answers and see. So A is Paris, and most people know that Paris is going to be the capital of France, so we can cross that out. And then B is Tucson, which you might know that's actually a city in the US. It's in Arizona, so we can cross that out. And then C is London, which is the capital of England, so we can cross that out, and then we're left with Bamako, which is going to be the capital of Mali. And then we used indirect reasoning. We eliminated all but one possibility because they were shown to contradict a given fact or accepted idea. And then we're forced to accept that the remaining possibility must be true.